Yeah, hi everyone. Thank you for visiting the talk about DAGify, the Enterprise Scheduler Migration Accelerator. Yeah, my name is Konrad Schieban. I'm a strategic cloud engineer at Google, working at Google Cloud Professional Services, specifically in the migration team in EMEA. So I help customers migrate to Google Cloud. Unfortunately, not with me here today is Tim Hyatt, who is working with me in the same team. He's a staff technical solutions consultant also at Google Cloud Professional Services, but he has co-developed this presentation with me and the tool. Quick shout out to my team that has worked on DAGify. Myself, Tim, Joanna, Harish, and Shreya had big impact on making DAGify work and help on scheduler migrations. So what are we trying to solve? So as I mentioned, I work in the migrations team in Google Cloud Professional Services, and often application migrations to the cloud from on-prem involve the migration of schedulers or enterprise workflow management systems. And the customers that we're working with, they often have a desire to move these systems to the cloud along with the applications. One of the platforms in the cloud, if you're migrating, for instance, to Google Cloud, is Cloud Composer, and we've migrated some of the workflows to Apache Airflow. Unfortunately, there is no direct, immediate migration tool. There has not been a migration tool that would automate all of this. And just as a disclaimer, those tools also work sometimes fundamentally different. So I don't want to claim that there's, for instance, feature parity between Control-M and Airflow, but they do have similar use cases that customers want to solve. So that may require thousands of human hours to convert these schedulers to Python code, to DAGs, and that is something that might be too much for organizations to consider at scale. That is why we took the challenge to actually implement a migration tool from such a scheduler, Control-M, to Airflow. It's called DAGify, and what this is doing is it converts the exported workflows in XML format to Python code that can be imported into Airflow. Yeah, you can access the tool there if you follow the QR link or this URL. It's open sourced on GitHub. We wanted to make it open source and extensible so that anybody who's using the tool can also contribute to it, raise issues, and so on. It is designed to be highly extensible and kind of a no-code tool, a no-code solution. So users would only specify their configuration, how they want to migrate their workflows in YAML format, rather than having to develop their own Python code. It also provides a report that provides a summary of the conversion and which job types could be migrated and which ones could not be migrated, so that you have an overview. Hey, your Control-M XML files has 1,000 different jobs. It has, 10 different job types, and DAGify could migrate, 800 out of these 1,000 and 200 not. Another disclaimer what the tool is, and that goes along the lines that I mentioned earlier, that these tools sometimes work differently, is that this is a migration accelerator. So it's a little bit too ambitious to say that you feed in a workflow file and it just does the migration 100% and you can use it in Airflow like that. But it provides the structure of the DAG. It converts each job to Airflow tasks. And also it maintains the dependencies in Control-M files as they, it will have the same dependencies in Airflow as they had in Control-M files. So this is how it would look like. So you start off with an exported version of the workflow on the left side. This is a typical XML file that is exported from Control-M with some bogus data. And once you feed it into DAGify and you run the conversion as an output, you would get a DAG that can be exported into Airflow. So how does DAGify actually work architecturally? So we designed the tool in a way that it is that it can potentially support several different input formats. So that is why if you start off with an XML file or any kind of file that can be parsed and understood, the intermediate format is what we call the universal format, universal DAGify format. Why? Because if you, let's say, you want to extend the tool to some other scheduler, and there are a lot of out there, you need to understand how to convert that, or how to parse it, how to make sense out of the dependencies, bring it into this intermediate format, but then actually the conversion engine to generate the report and generate the DAG will just have work as is. So it has an interface to this DAGify format and will generate the DAGs correctly. So once the source XML is parsed into the universal format, then there is a report engine and a conversion engine. And based on conversion template files that you define, the conversion engine will map source fields, like you have them in the source file, to target fields that are defined in your DAG. Between the source and the target field, there's also a rules engine that applies certain rules to input parameters, to those source fields that you find in the XML. What do I mean by that with the rules engine? You can think of it in that way that those are small Python functions that you can also define and supply yourself if you want to, that apply certain rules to these XML fields. Like for instance, job types in XML, they can have certain characters that are not allowed. So let's say they have, for instance, something like a hash or an ampersand or something like that, that would not be allowed in Python code, and that is then converted into some other characters that would be allowed in Python. So some aspects of the DAGify engine. So as I mentioned, it is a no-code solution, so you don't necessarily have to write Python code to convert your source files. You specify templates that contain the source to target mapping. So which job types in Control-M do you want to migrate to which operators? So for instance, as an example, in a YAML format, you would specify, hey, the job type command, something like that, that would execute a CLI command, should be migrated to the bash operator. Or it should be migrated to a different operator, like for instance the GKE start pod operator, if that is the way that you want to migrate. And as I just mentioned, there's a rules engine. Those are the small Python functions that are applied to any fields. In the YAML that you use for your conversion, you specify which rules do you want to use. Like for instance, do you want to convert, or do you want to make all uppercase letters in your Control-M jobs to lowercase, something like that? Do you want to add some randomization to make sure that all jobs are unique? That is what the rule engine is for. And then in the configuration file, that is one file that you have in your DAGify configuration. It's one YAML file where you define you want to use which templates you actually want to use. And finally, there's a reporting engine. I briefly touched upon that earlier. It captures information on how much of the source file can actually be migrated and how much has to be manual at the end of the day. A couple of features of the tool that I want to go over. So the first thing are DAG dividers. So imagine you have a Control-M XML that contains something like 1,000 or 2,000 different jobs, and you want to convert that into a DAG. So one thing that you can do is create a single DAG that also has these 2,000 jobs. It might be a super long Python file that is extremely complicated to comprehend. Something that you can do instead, however, is divide the DAG based on certain XML tags, and Control-M files are divided by, for instance, a folder, a smart folder, an application, a sub-application, so that is very specific language to these Control-M files, but it could be based on any XML tag. But if you specify, for instance, the DAG divider sub-application, that will generate a new DAG for each sub-application. So specifically, this is how it would look like. So if this is your XML and you specify the folder name as your DAG divider, it will create one DAG for all jobs. But if you specify the DAG divider of application, then for each application, so in this case these two, it will create a new DAG. It will place these into one DAG and this into another one. So what happens if these jobs have dependencies in Control-M between each other, but you place them, you place jobs into different DAGs because that's how you choose the DAG divider. So let's say there are jobs in two different sub-applications that are dependent on each other. Then DAGify will create cross-DAG dependencies using external task sensors. And that is just one illustration what would happen. One job from one sub-application will then be an upstream dependency to another, or an external dependency to a task in another DAG. Then scheduler migration. So here is one fundamental difference between Control-M and Airflow. So in Control-M, jobs can have individual schedules, and there can be several, well, if not 1,000 jobs in one workflow. And in Airflow, the schedules are on a per DAG basis. So this causes a little bit of friction with the conversion. So the idea is that you choose the DAG divider accordingly, that you have the same, the correct schedule for all tasks that are in one sub-application or in one application, for instance. So if you have several jobs that have different schedules, but they would be placed into one DAG, then this causes a conflict and DAGify will only choose one schedule for them. And then the reporting engine, so we're going to see one example in just one moment. So there is a generation of a report in text and in JSON format, and what it will report on is the amount of operations that it knows how to migrate because it has the templates for it, the amount of operations that it does not how to migrate that you need to do manually, the types of operations that it has found, so the different types of operations that it could found, and which templates you're actually used for the conversion. So this is one sample report. So here on top you see job types converted, 1 out of 2 in this example. Also percentage-wise, the amount of jobs that it could convert, also in absolute numbers and percentage. And some information on, hey, what kind of job types did it find in the Control-M file? Yeah, which jobs, with what name could it convert and which ones not. Okay, so let's have a look at it in action. I chose not to do it live because who knows what happens on a hotel Wi-Fi. So I would have shown exactly that. So it's a command line tool, as I mentioned. So we start off by cloning the repository. So that's done pretty quickly. Let's navigate into the directory. And what you see here is, so DAGify is a Python executable, right? So there are some dependencies that you need to install. It also comes with some sample data that you can test with. It also comes with a make file that we start with. We run make clean to create a Python virtual environment and install the Python dependencies there. That just takes a moment before we can then use it. So this will create the virtual environment in just one moment. And then we just have to run source VM bin activate to jump into that virtual environment. And now we can run DAGify as a command line tool. So let's do that. First with the -h parameter to show the help page and what kind of options there are. So a couple of parameters is the source path to the XML that you feed in, the output path where the DAG is being generated, and then if you want to create a report or not, so -r. So we choose to use all of them and apply DAGify to this source XML that is provided in the sample data folder. It has something like 10 different jobs that you can see here. That is how all the jobs are defined here. And yeah, you see application, sub-application, and the task type. And one thing that is interesting here is if you want to understand the dependencies between the tasks, you need to look at the in conditions and out conditions of the file. So out condition means that, hey, this job is actually an upstream dependency in Airflow language to the next job that has an in condition with the same name. So now let's run it, DAGify.py -s with the source path, sample data, Control-M, and then the XML file, -o with the output directory, let's call it output folder, and then -r for report. We run it. And since this file is small, it is almost done instantaneously. Here we have the detailed report that shows us, hey, we have found one job type here, it's been converted, because we use a template that knows how to migrate these job types, and it will use the Airflow bash operator. So let's open the DAG that has been generated. Yeah, it creates a operator based on the YAML template that you specify, and then it also creates the dependencies. Here, there are only internal dependencies within the DAG using the bitshift operator. So to finalize the demo, we are going to upload that DAG, that converted DAG-py into a cloud storage bucket where it can be picked up by Cloud Composer here for illustration. But again, this is not specifically a tool for Cloud Composer. This can be used for any Airflow environment. It will take just a moment for Airflow to find the DAG. That is why I needed to stop the recording, and then you see under in Airflow you have this converted DAG being created. Right, and then what you should do, so this is the graph that is being created based on the Control-M file that we have seen, and you should validate that the dependencies are correct. They should be correct. Yeah, based on what we can see here, and yeah, that is just the code of the DAG, but that concludes the demo. That concludes the part of the demo and the presentation. So here are two links so you can see if you follow that QR link, you can go to our GitHub repository and also read up more in our blog post. If you have any questions also later on, feel free to contact me either on my LinkedIn page or contact me on my google.com email address. Very happy to chat about scheduler migration.